Hi guys, today we'll be solving LeetCode 322 coin change problem. This is a very well-known DP pattern. So as I said, DP, it is dynamic programming problem. We'll see how it goes by, what is the brute force, what is the optimized approach for this problem. In this problem, we are given a set of coins in an array. So one here denotes coin that has denomination 1. Denomination 1 means which has value 1. 2 denotes 2, 5 denotes 5, a coin that has value 5, right? So this is suppose 6 here, we are given the amount 6, suppose, right? They are asking us to create all possible combinations of these coins to make this amount. Okay, all possible combinations of these coins to make this amount. So how can we go about it? The easiest possible way is, you can say 5 comma 1, right? It can be 2 comma 2 comma 2, or it can be 2 comma 2 1 1, or it can be 2 comma 1 1 1 1, right? And then again 1 1 1 1 1, everything, right? So what are the possible ways? 1 2 3 4 5 possible ways. You can get more possible ways again if your amount is more. The permutations will increase, right? So what they are asking us to do is give out all possible number of combinations, not the exact combinations. Even we can do that too if we have an array list, if we are maintaining array list or essay. So all possible. So 1 2 3 4, and then the next ones which are coming in. So how can we go about this? Let's try to see the brute force way, right? Go brute force, go easy. Suppose you have 1 2 5 as coins. At 5 you have two options again, to choose this into a final path or not choose this. 0 denotes not choosing it, 1 denotes choosing it. One more thing that I missed talking about is they have given us an infinite supply of the coins. So suppose if the amount is 1000 and you have 1 2 5, you have 1000 coins of 1, maybe 1000 coins of 2, and maybe 1000 coins of 5, right? I mean infinite, there's no limit to it. So firstly let's look at the not choose case, right? If we don't choose 5, if as we have not choose 5, so 1 comma 2, the amount is still 6. We have not chosen it and none of the coin are contributing to the amount. So 1 comma 2, the remaining coins, and 6. I'm going right to left in this case, right? At 2 again we have two choices, 0 comma 1. If we choose 0, 1 with 6. At 1 again 0 comma 1. If we choose 0 again, none of the coins remain 6. But at 2 you have 1, which will give you 1 comma 2 back. Why 1 comma 2 back? Because once you choose coin 2, you can again choose coin 2, right? You can again choose coin 2, 1 comma 2 back, but now the denomination has changed. So 6 has reduced to 4 now because we have chosen 2, right? Again, when you have 1 comma 2, same set of coins, and you have 2 again, 4 has reduced to 2. Again, if you choose 2, 1 comma 2 0. This is a way you have found out through which you can get one possible combination. The other way is 1 comma 2 comma 5. If you choose 5, 6 minus 5, you'll be remaining with 1. You have chosen it, you can choose it again as well, infinite supply, right? Again choose it 5, 1 comma 2 comma 5, same set of coins, but now the denomination is in negative. Do we want negative denomination? No, we want it to be 0. I mean 6 should be 6, it should not be minus 10, right? So 0 case as in not choosing it, 1 comma 2, the same thing again, remaining with 1. If you choose 1, if you choose 2 again, same set of coins but minus 1, negative. This is not where we want to go. 0 means we are not choosing it, so left with 1 comma 1, right? So not choosing it, no coins left, but still denomination is there, no possible way to go forward, right? This is not our answer, but if we choose 1, we still have the same coin. That is not a problem. Even if you have 10 coins, that is not a problem. Our amount should be 0 at the end, right? So if you see this solution, you will get a probable answer with the recursive way, right? What will be the time complexity? Again, you have two different ways, right? Two different ways. So and your tree is merging out between two branches every single point, I mean every single recursive function you give, it is merging out two branches, as in it is giving call to the same function twice in that function, right? So it has to be exponential 2 raised to, we don't know the term yet, right? So what can be the longest branch? That is what we want, right? What can be the longest branch? If we have 6 here, we have denomination of coin 1, which is the minimum coin. If you see the limitations, which is the minimum denomination coin, a coin cannot be 0 or negative, right? So minimum denomination 1. So here you have 5. When if you start from the right, not choose, then 2, not choose, then when you come to 1, choose, right? At the end, the where you're gonna get an answer is 6 times of 1, not choose of 2, not choose of 5, right? So that is, if you consider this thing as n, right, length of the array, and you consider this thing as m, so your biggest branch will be not choosing 5, not choosing 2, and choosing everything of 1, that is 6 times of 1 and the n, right? So n plus m, this is the recursive approach. Let's go about it. The recursive solution, so we'll call helper, we'll return result. I don't have the result yet. Int result, this will be initiated by default by 0. It's global variable. Public void, let's do void recursion first. Helper, what will we require? We'll require the coins, we'll require the index, we'll require amount, we'll require current coins used, and coins used, right? So what will pass? Coins, index should be starting 0, then amount should be amount, and coins used will be 0. We are not using any coins at the start. Base condition, logic, first not choose, we'll call the same function coins. If you are not choosing, we are skipping the index plus 1. Not choosing means the amount is not reduced. Amount, coins used is still the same, right? Because we are not choosing means will not increment the coins used. But if you choose, we have coins, we can choose the same coin again, so I'll stay at the same index. Amount will be amount minus coins of the current utilized one, and coins, because we are choosing it, we'll add the current coin, right? We'll do just a minute, this dot result, as we discussed, the maximum number of coins can be the number of amount, so we'll do amount plus 1, right? This dot result, base case will be if, firstly we'll check if amount equal to 0, then we'll do result is equal to mat dot min result comma coins used, right? And then return, we'll update the result and return. But if amount is less than 0, which is not what we want, or idx, or if we have utilized all the coins dot length, then return. I mean, we have utilized the whole array, not, it's gonna give us the index out of bounds error if we do idx plus again, right? Plus 1 again. This should be working. It gives, oh I'm not checking. Oh yeah. So if result equal to amount plus 1, as in there can be a case that you cannot form any coins, right? So for example, you are given coin 2 and you have to form amount 3, right? No matter how many iterations of coin 2 you use, you cannot form the amount 3, right? So just in that way, return -1, or else return result. Okay, this makes sense. Let's submit it. Oh, okay, time limit exceeded. Let's try to do it int base. Let's remove the result, we don't need this. We'll return the helper directly. We don't need this. We'll return the coins used directly. Coins used, we'll return -1 here. Let's see what we do of -1. Int case 1 equal to int case 2 equal to, what do we return back? But if case 1 returns us -1, right? So we'll return case 2. sorry, yeah, case 2. Same, if case 2 equals to -1, return case 1. If both are -1, it's still fine. We'll return mat.min case 1 comma case 2, and we are doing a return on helper here. It will return -1 if we are not able to form any coins. Oh, I didn't change it here. Okay, that's it. Let's try to optimize this one now. So this is a recursive function. We are calculating the same things again and again. I'll tell you where. So let's suppose you have 1, 2 here, and you have denomination 2 left, right? I am choosing 1, that's why 1, 2, 0. But if I don't choose this one, 0, I'm left with 1 and 2, right? Now if I choose 1, I'm left with 1 and 1. Have we solved this problem before? Yes. 1, 1 is here. Here again you will do the 0 case, here again you will do the 1 case, which you have done earlier as well, right? This is just a minor example. If you have a bigger array, there will be so many problems that are repeated again and again. That is why we don't get a memory limit exceeded, but we get a time limit exceeded, right? So the same problem, you are doing it again and again and again and again. So that is something you don't want. How can we optimize this? We can try to memorize these problems, and whenever you get 1, 1 again, you can use this result here itself, so that you don't have to do 0, 1 again, right? Let's try to memorize. Okay, so with coins 0, I'm taking it from 0. I'm trying to do a matrix. I'll tell you why we are taking 0 here, and you're starting your amount with 0. We had 1, 2, 5 and 6, 1, 2, 5, and then all the coins 6, right? Okay, with coin 0, can you make 0? There's no possible way. So 0. With coin 0, can you make 1? No, you can't. So it will be infinity. With coin 0, can you make coins 2? It will be infinity again, right? You cannot make it. You'll require infinite number of coins which are termed as 0, right? So infinity, infinity, infinity. Okay. With coins 1, can you make 0? No, you can't make 0. Similarly, with coins 2, can you make 0? No, you can't make 0. With coins 5, can you make 0? No, you can't make 0, right? Now, with coins 1, how many ways do you have to make 1 with 1? I mean, 1 coin and the amount 1. You just have one way. With coins 2, how many coins? With coins 1, how many coins you require to create the amount 2, right? 2 coins. Similarly, how many coins were here? 3, 4, 5, 6, right? Now, some things might change here when you come to 2, right? With coins 2, 0 we saw. With coins 2, can you make 1? So with coins 2, can you make 1? No, you cannot make 1. That means you just have the 0 case, right? With coins 2, so we had 1, 2 as of yet, right? We'll have 1 case, 0 case. If you take the 1 case and you have the coins 1, right? 2, denomination coin 1. These are the 2 coins you have as of now. If you take the 1 case, that is 2, 1, then 1, 2, you can use the same coin but -1, right? So you don't want to go minus, you only have 0 case here. When you have 0 case, it is 1, the remaining number of coins, and the same value, 1, 1. Oh, have we solved 1, 1 before? Yes, we have. 1, 1, that is the value just above, right? So you can term as the 0 case as the value just above. The 1 case we'll talk about later. Okay, the 0 case value just above, that is 1. 1 case we cannot take, that's why just 1, right? Now when you come here, if the denomination of coin is 2, right? So you have these 2 coins, 1, 2, denomination of coin is 2, right? The amount you require is 2. So it will be 1, 2. If you use the coin, 0, and if you don't use, you still have 1 comma 2 comma 2, right? So 1, same number of points because you are not using it. These are the two same conditions, and this will branch out again. If we had a recursive problem, this was going to branch out. But hey, have we solved this before? 1 comma 2, these two, and the denomination of coin is 0, right? So just 2 steps back, that is 0, and we are using the coin 1, so 1 plus 0. But this is the case 1. What were we doing in recursive solution? We were taking minimum of case 0 and case 1. We need the minimum number of coins to make the value 6, right? 1 plus 0, what is the 0 case? We have not used any coin, and 1 comma 2. 1 comma 2, as I said earlier, 0 case just above, 1 comma 2 just above. So 2 comma 1, right? 2 comma 1 plus 0. It's case 0, case 1. What were we doing in recursive solution? We'll do the same here. We'll take the minimum of them, right? 2 comma 1 minimum is 1. Similarly here, we'll go a little fast now. 3. What is the 0 case? 3. What is the 1 case? 2 steps back. So 3 comma 1 plus 1, that is nothing but 2, right? Similar for 4, 2 steps back, this is 2 again. For 5 it will be 3, for 6 it will be 3. You can cross check too. For 2, what is the minimum number of coins you will require to make the amount 6? That is 3, right? Okay, this makes sense. Let's try it for 5. For 5, can you make 0? You cannot make 0. Can you make 1? Right? You cannot make 1. With 5, we'll change this. With 1 comma 2 comma, now you have 5 and the value is 1. If you take 1, it will go to negative, right? Minus 4. We have seen it here. But if you don't take it, right? So 1 comma 2, not taking it, 1 comma 2, value 1. 1 comma 2 value 1. Have we solved this? Yes, we have solved this. 1 comma 2 value 1, just the case above. That is 1 here, right? 5, similar to this. 2, can we see just the value above? 1, same. 3, again same. 4, again same. 2, just the value above, because the other thing will be negative. But now if you see the next case, 1 comma 2 comma 5, but the value now is 5, right? The amount is 5. So again choose, not choose. Not choose means 1 comma 2 comma 5. As I said, not choose scenario, just the case above. But choose scenario, 1 comma 2 comma 5. Now it's not negative, so we are not like neglecting it. So now it's not negative 1 comma 2 comma 5, so this will be 0, right? 1 comma 2 comma 5, have we solved this? Yes, 5 steps back, right? Just 5 steps back. So it will be 3 comma 1 plus 5 steps back value, that is 0, right? So mat.min between 3 and 1, that is 1. For 6, again same, mat.min between 3 and 5 steps back, that is 1, right? So 1 plus 1, it's 2. At the end, the end index, the end value of the matrix will give us the answer, right? The end value of the matrix will definitely give us the answer. So we can also cross check. To make value 6, what is the minimum number of coins? 1 and 5. Just 2 coins will be required. We have the answer 2, right? In this problem, what will be the time and space complexity of Mn? Will be the time complexity, because we are traversing over the matrix, and the space complexity of Mn again. Can we improve this? I think we can, because in every single row we are just utilizing the row above. We are just utilizing the row above. With 1, 2, 5, was I checking what I have just with 1? I'm not checking like that, right? I'm utilizing just the row above and the values at the back. That is still fine. I mean, I'm just utilizing one row. So can this be improved? Yes, this can be improved. So we will be utilizing just one row. The time complexity still remains the same, but the row, but now the space complexity, it's O of amount only, right? O of amount plus 1 basically, because we're including 0 as well. Let's try to code it out. Let's try to optimize it. let's stay over here. So what were we requiring? Int and okay, let's int array. We'll start with 2D array first. New int. What we need, suppose if int n is equal to coins.length, right, and n plus 1 because we are taking 0 as well, and we need amount plus 1 because again we are taking 0. For int I is equal to 0, oh, let's do I is equal to 1, or let's do j is equal to 1, j less than amount plus 1, j plus plus. We don't need to do infinity for the first row, but we can do amount plus 1 because that will still be proclaimed as infinity for us, just because you cannot make more than amount number of coins, so amount plus 1 will still be the same thing. dp of 0, the first row, and j is equal to amount plus 1. This sounds good. For int I is equal to 1, I is less than n plus 1, I plus plus. For int j is equal to 1, j is less than amount plus 1 because we are taking again 0 indexed 1, and j plus plus. Now if, as we saw, if you cannot make a positive one case, right? If your j is already, if j is less than coins of I minus 1, I'll try to explain this more, right? So if j is less than, in the case of j is equal to 2, right, 0 1 and 2, in case of j is equal to 2, and when your coins, I mean when your I is 3, I mean when your coins plus 1, when your original coin is 5, were you able to make the value 2 be with 5 as a coin? No, we couldn't have, right? So until j is equal to coins, you cannot make the value 2. You cannot make the actual value, it will be negative, so we don't have to count the negative. So until j becomes equal to and greater, we don't have the 1 case, we only have the 0 case. So we'll write the 0 case first. dp of I and j, as we discussed earlier, 0 case is just the column above, just the same column above, just the row above, right? So I comma j, here dp of I j, is equal to mat.min, again the same thing. 0 case will take it first, dp of I minus 1 and j, and 1 case was what, considering the same coin, and dp of, so same column, and you were going the same steps back. How many steps back? The number of coins steps back column, right? So j minus, what is the number of coins? Coins, oh I'm so sorry, j minus coins of I minus 1. Does this look good? Yeah, sounds good. So at the end we have to return the nth column and amount plus 1, right? But we have to first check if dp of n amount equals to amount plus 1. If it's still equal to amount plus 1, that means we were not able to make any permutation of the coin that sums up to the amount, right? So return minus 1, or else return dp of n and amount. I don't think so I'm making any problem. Yeah, it runs fine. So if we try to submit, it's submitted. No time limit exceeded. Can we improvise this? Yes. So let's reduce. We don't require this thing. The 0 case will be just the same case, right? Oh, if I'm not even changing this, I mean the 0 case, why do I need to write it differently? I'll just change this, equals to, let's change this here. I don't need a whole else case now. 1 1, this looks good, amount plus 1 looks good. We need to change this here and return the amount. Oh, I didn't change it here. Oh, works perfectly fine. Even better time complexity if you see the space.